All right, so this set of notes is going to be all about metallic bonding. Metallic bonding is one of the three types of chemical bonds, and metallic bonds happen between different metal elements. And we can see here on the periodic table, all the silver ones are going to be the metal ones, and generally it's towards that left side. So things that are important to know about metals is that they have low ionization energies and low electronegativities. So what that means is they don't want any more electrons. That's low electronegativity. So they don't really want any more electrons. And it's really easy for them to lose their own valence electrons. So not only do they not want to take any more, but they want to lose theirs. And these are important to understanding metallic bonding, that they don't want their electrons. So beryllium is a metal. It has two valence electrons, and it wants to lose both those valence electrons to have a full set. So it becomes beryllium plus 2. Sodium has one valence electron, and to get a full set of valence electrons, it wants to lose that one electron, so it becomes sodium plus and loses that electron. And another metal would be aluminum. Aluminum has 3 valence electrons, and to have a full set of electrons in its energy level, it wants to lose all 3 of those valence electrons. So metals want to lose their valence electrons to get that full set. But when we are in the real world, we're not just dealing with one atom at a time. We're dealing with large groups of atoms. So what ends up happening is a lot of these metals are together, and they're all losing their valence electrons because they don't want them. And it kind of becomes what we call a sea of electrons. So now, if you take a look here, we have a bunch of sodium ions that lost their valence electrons, so they're all together. And those valence electrons are what we call delocalized. So they don't belong to any single one of those sodium ions anymore. They're kind of just out there floating around. And we use the term sea of electrons to describe them because they're flowing around in between the sodium cations. And I got a little animation here. So we know those electrons are negative. They're kind of just flowing around the sodium, those positive sodium cations. And the negative charge of the electron kind of holds them together, because you would think positive forces or positive charges generally want to push each other apart. This negative sea of electrons is holding them together. So these delocalized electrons that have a negative charge hold the positive cations together, and it gives metals some very, very unique properties. You could flatten them and shape them really easily. So we have aluminum foil, we have copper wire. The electrons are constantly moving around, so it allows them to transfer energy very well. So energy can be in the form of heat. So that's why pots and pans are metal. And we transfer electricity, which is energy, through metal wires. And you can see here's some power lines. We have the wires made of metal, and they're held up to the tower with non-metal insulators that prevent electricity from going into the tower. So we could also put different metal elements together to form metallic bonds. These are called alloys. So when you have more than one type of element in your metal, it's called an alloy. So here, I decided just to put sodium, beryllium, and aluminum together because those are the ones we looked at before. They all have different charges, meaning they all donated different amounts of electrons into the sea of electrons. But they can all still bond together. So many metals that we use in everyday life are alloys, meaning they are more than one type of metal bonded together. And sometimes we do this to increase either the strength or the corrosion resistance, or maybe the density or the lightness of the metal alloy. So an example would be bronze is copper and tin. Brass is copper and zinc. There are many, many types of steels, all that they have in common is they are iron mixed with other elements to give it different properties. And we have titanium alloys, which is titanium and other elements. And we use titanium because it's extremely lightweight and extremely strong. So we use it in aerospace technology like plane engines, on spaceships, and it's very corrosion resistant. So we can use it in human bodies as well. So that's a picture in the middle. That is a picture of a hip replacement.